Uh, Thank you, Lydia, and thanks a lot, everyone. I understand this is the third back-to-back session that you guys are attending, so I hope you guys are awake, you had your coffee breaks, and my presentation will be interesting enough to not put you to sleep. So, quick, brief introduction. Lydia gave some idea about where I come from. I have been in the field of automation for more than 10 plus years. I started off as a developer, but then I loved automation enough to switch sides. So for the last 10 years, I have been doing automation, leading and managing test teams, execution teams, and trying to roll out best practices in my teams. I have worked in the government, in advertising, and education sectors till date, and I currently work in a government consulting company called Carson Solutions. We are based in Herndon, in the Virginia. So quick note, my office hours are actually not today, they are tomorrow. But you can reach out to me on LinkedIn, Twitter, or if you see me in person, please feel free to talk to me anytime. With this brief introduction out of the way, let's get started with my main topic, UI automation and why it's not free. One of the questions I had, like, why is UI automation popular? And I was like rethinking, should I even ask this? We have 650 people gathered here today because UI automation is popular. Everyone is using it, and we are using it in multiple ways. But just a quick 2-minute intro on why it's so popular. One of the things is it's open source. Since Selenium was introduced 10 plus years ago, it has been used in so many teams that it's been used extensively. Whenever someone talks about starting automation, the first thing they think of is UI automation. It's almost like the word automation is synonymous with front-end automation. The best thing about Selenium WebDriver is it's open source, and all the tools that you need to work with, like Java, Cucumber, Python, all of these are available to you free of charge. There's a lot of online documentation available to us. So someone tells you to start automation, this is the way to go. So it's really, really popular because of all these features. Another biggest advantage with this is functionality testing. This is the most important aspect that UI provides to us. You are actually imitating the user interactions. What the end user is going to do on your web application, you are exactly testing those steps and scenarios. So that's a pretty big advantage with Selenium automation. One fun fact about this, I had taken my kid to work on the Take Your Child to Work day. He was a 5-year-old at the time, and I showed him a test running on my browser without me touching my keyboard, typing in anything. And he literally thought it was magic. So it was a pretty good feeling for me to feel like, oh, my mom performs magic at work. So that's a pretty good role description, and I would always like to put it on my resume if I can. So, but I actually like the feeling that I get. When I complete one test case, I get it to run successfully for the first time on my screen. After that, I don't want to see it running, sit there watching it just running in. I would prefer Jenkins to do that job for me, but that's a visual validation that you get, that you are actually testing your application when you're doing this UI automation. So these are all the great things that UI provides us. But then what happens? UI also comes with its own sort of baggage. So before we delve deeper into what baggage it brings and why I think that it's not free, even though there is no license requirement, there is no initial investment in terms of money that you need to put in before starting UI automation. So just a quick couple of things. Most of my work has been focused in Java, and I have worked on Python and other scripting languages, but mostly it's Java. So all my presentation examples will have some sort of object-oriented concepts in that. Also, I have been using behavior-driven development. So instead of test cases, I might say scenarios as part of my examples. But again, irrespective of all of these things, the experience that I have gained and the values that I have learned, lessons I have learned out of this, they are not language specific. They can apply to anyone with using any language out here. And one last thing, when I talk about UI test, I'm normally talking about the automated UI test and not the manual UI test. So just with these two disclaimers out of the way, let's dig deeper into the baggage that UI automation brings with it. And this is something that all of us who have been using UI automation are aware. Long execution times. A test, if not written correctly, can go on for a long time. And the longer it runs, the more chances of failure it brings with it. So, and it takes time for UI to run because we know it, the browser has to be started. You have to navigate to the page of interest and then perform the actions and the validations that you need. So that takes time. But if a test not written properly, will really mess up your whole framework. So let me give you an example. So long time back, this is around the time when we just had Selenium 1 versions. Selenium 2 was still far, far in the future. Our team had started with automation. We decided, okay, let's start with automation. It was sort of the new thing to do at the time. So we started off with UI automation. We started with a basic CRUD testing CRUD functionality. Create, read, update, delete. Just 4 things for every entity that we had in our application. We built a framework around Selenium WebDriver, Selenium, and then we ran it. It was pretty successful. So then we got this task. Now that you have your proof of concept ready, why don't you guys start converting all our manual regression into automated? And we took on that job. Our productivity was determined depending on how many UI tests, manual tests, we converted into the automation. And it took us a lot of time. Since our productivity was determined on that number, we hired a lot of people to help us with that. And at some point, we reached our goal. And this is what we had. We had around 1,000 plus tests. These were running for 22 hours every day. And we were using parallel execution. So yeah, we were not running sequentially slow by one after another. It was parallel. We had 100 servers under test. We had 400 agents running against those servers to get our test done. And our pass rate, I don't think anyone would guess here, but it was 70% passing. So if we ran 100 tests, 30 of those were failing. So that was a huge amount of effort for us to figure out why the failure happened, to analyze the test, and to get the feedback to the development team. And that was taking us 2 to 3 days to just figure out what went wrong. So the execution happened on day 1. We figured out the problems by day 4, and then the feedback went to the development team. So as you can see, that was not a great idea out there. And one of the reasons why this was happening is some of our tests were taking more than an hour to execute. We had huge workflow tests, which took us an hour. So if that test failed, we used to spend 30 to 40 minutes just waiting, looking at the screen, waiting for the test to fail. Once it failed, then we dig deeper into the troubleshooting. So not a very great idea, just spending a lot of our time on coffee breaks. So this was one of the biggest problems. And out of this, right now I call it an experiment, but this took almost a year for us to work on. So out of that, we learned quite a few lessons that I just want to share today. One of the biggest ones is what to automate. You might have heard this thing from a lot of people, but this is really, really critical. Figuring out what is the most good automation candidate, the best automation candidate, and then automating it rather than just blindly converting from manual to automation. That's something we really, really need to take care of when doing UI automation. Second thing is one of the biggest things, too long a test, break it up. If it's running for more than 5 minutes, 10 minutes, make sure you are breaking that test up because maintaining it, troubleshooting it is always going to be a pain in the long run. And last thing, but not the least, remove flaky test. I think Angie, those who attended Angie's workshop in the morning, she talked about the flaky test. But just make sure you are not removing and throwing it away. Make sure you pull it out of your regression suite, work on it, and fix it in such a way that it's going to be more robust, running more stable, and then put it back into your regression suite. So this is very important because we always spent a lot of time on tests which are passing 1 week, failing another week, and there was no change in the application code underneath for them. So these are the few important things that we learned out of that experiment. But other than the long execution times, there is another thing that's most important with UI automation, maintenance. A lot of people know this issue, and just in a believe me, I really identify with this guy because right now I'm coming out of a project. I worked on it for 2 months. I was refactoring code that someone else had written, and that was not fun. Every day I was like literally ready to bang my head against a wall, just like, what am I doing? Why do I have to do this? But maintenance is something that we all have to live with. You can't just push the work and say, oh, ignore it at any point. So as you say, change is constant in life. our application is also going to change all the time. So it's not going to, the UI of the application is not going to remain same consistently. And one of the things that happened was in one of my teams, we had spent a lot of time and effort getting to the level of having good automation coverage. We were almost in sync with what the dev team was doing. So dev team had an enhancement, we had automation to support that enhancement. And then all of a sudden there was this product modernization drive. They wanted to change the whole UI. The functionality of the application remained the same, but the UI look was outdated, so they decided to change the whole UI. And there went all our efforts down the drain. Not a very good feeling. But see, if I had known then what I know today from Raj's presentation about dynamic locators and using AI to fix them, that would have saved us a lot of time. As he mentioned, AI can identify the locators which are changing, fix them, your test won't break at all. That would have saved us a lot of time in the maintenance. But since that is not something that was available to us then, and I'm hoping that moving forward, you guys, all of us here will be able to leverage the AI, that would be a great one. That will reduce a lot of strain that we have with UI maintenance. So as we all know, UI maintenance comes with a huge cost, time, effort, and sometimes it's not fun to fix a code which someone else has written. So this is the biggest baggage which I feel UI automation carries. And I think it was there in one of the surveys that was carried out, which was sent out to all the automation engineers, asking them, what is the biggest challenge you have in your life as an automation engineer? And maintenance was the one that they answered with. So this is one of the biggest baggage that UI has. In addition to these two, there is one more. There are a few more things that come up. One of them is when you're testing the UI from the front end, you are not always testing the business logic. Sometimes your business logic is hidden in the web services layer. Sometimes it's there in the database layer. It's in the stored procedures. So you may not be actually reaching that point to test that functionality all the time. So just testing the UI is not enough. Second thing, when you're using the UI for testing, you cannot say that you are done, your test complete, till you run your test on different browsers, different environments, and if you're in the mobile world, then against different devices. So that's a lot of work to say that you are test complete. And last but not the least is scalability. So it's very easy to write new tests, but at some point you will reach a point where the regression suite is so huge, the execution time keeps on increasing, and you run into the problem that we ran in my example that I showed. Unless you have a sophisticated system which will say, okay, your code has not changed in this area, so I'm not going to run the test from that area. There might be tools out there, but they are not open source for sure. So scalability is a big thing that you need to keep in mind when working on your UI automation test. So, sorry, I went a little bit ahead. So if we cannot depend on our UI automation to help promote our builds, what can happen next? So a few years ago, I came across this picture. This is the pyramid, as most of you might be aware of. It was proposed by Mike Kahn, and it's been well documented in the book, Agile Testing, by Lisa Crispin and Janet Gregory. We actually have Lisa Crispin attending this conference. So if you meet her, she's the expert on this, so you can talk to her about it. So this pyramid actually was like a light bulb moment for me. When I saw this image, it was really like, oh, this is exactly what I wanted to see. Because at that time, my team was literally drowning in the burden of our huge UI regression suite. We had a little bit of API and extremely little unit testing available to us. So we had the perfect anti-pattern that we call as the ice cream cone in our team. We knew, it's not that we were not aware that we were on the wrong path, but we were having a tough time convincing the decision makers that we need to change our strategy. We shouldn't be just focusing on our UI test for testing the functionality. We need to do something different. We need to diversify. So when I saw this pyramid, it actually gave us that roadmap, and that's why I love this pyramid completely. So as you can see from this pyramid, as you go from the top to the bottom layers, your tests become much, much faster. Unit tests are much faster than your UI test. They are much more stable than the UI test. And you get immediate feedback, less effort. So there are a lot of advantages if you're pushing your test down to the lowermost level in this pyramid. So since looking at the pyramid and I was able to convince my teammates to join this model, I have been literally using it as my roadmap. So The biggest thing with this is it's just a roadmap. You can use it or customize it depending on how your team works and how exactly you need it to work for you. But it at least gives you that guideline. So let's take a deep look at each of the layers that we have in this pyramid. But before we go there, I just want to get a quick idea about how many of your teams have unit testing coverage? Some coverage. Wow, okay. And how many of you have 80% code coverage using unit test? Wow, see? So it was almost 80% of your people here had unit testing. So you have it there, but it's just not at the level that normally most of the teams would wish for. So unit testing, from my point of view, they are really critical tests that we could implement. They are really granular. They test the smallest thing that you write in your code. And they are really helpful, much, much faster than any of the upper layers that we have seen. One of the things that with unit test is, though, we always consider it as a developer thing. It's not something that we testers are doing. It's something like it's on the other side of the fence. The developers will be doing the unit test, and then later on, the control sort of comes to us. But I sort of completely don't agree with that type of approach. Quality is a team responsibility. So any of this, we can do it on our, should be a responsibility of the whole team, not just one part of the team. Also, one thing that I need to note is these days, companies are looking for people who are like full stack developers. They are expecting developers to do the automation for us. So if that's the case, then why we as testers and as automation engineers, why can't we also move on to the other side? And unit tests are actually the best way. They're the nicest stepping stools we can use to, if you want to learn more about development or technical stuff. They are simple to write, and you always have the development team to help you out if need be. Luckily for me, all my development teams have been really, really great with help, and there's been a lot of collaboration with them. So I always feel that unit tests should be given a little bit more importance in our tester domain, even though it's always considered to be on the other side of the fence. So another thing with unit tests is most of the time it's always a good practice to start off unit testing. If you're starting an application from scratch, make it a best practice. I need to have unit test if I'm starting a new application. But that's not always possible. Most of the time we end up with in teams which already have an application in place, but no unit testing or really bare minimum unit testing in there. In those scenarios, what we can do is try to roll out this best practice as for every enhancement that goes out, at least try to put unit testing for that. So you're not trying to do everything in one day, but little by little, in small steps, you're trying to achieve your goal. You can start off using some tools like SonarQube and Jenkins, which will give you the coverage of unit test. And that will, you can say, okay, for today, let's say the threshold is only 25% because we don't have enough unit tests. But as and when we go and increase our unit test repository, we can keep on increasing that threshold. The number that you finally stop at can be something that may not be 100%. I would like it to be 100%, but that's not always possible. Time, energy, resources, a lot of things come into picture. But it should be a number that everyone on the team, on your team, is okay with. If they say we are okay with 80%, we can stop there and at least get our unit testing to that level. So that way, you can literally leverage this really great testing layer that we have out here. Again, SonarQube metrics, if you have used SonarQubes, it's a really great tool, not just for unit test coverage, but also for static code analysis and a lot of other things. You can integrate it with Jenkins, and you can put a lot of gates and parameters. So you can say if the threshold is not reached, your build is not going to be promoted to the next level. So those are the few things that we can look into when we are looking at unit test. The next layer, API testing. So don't get scared with looking at the cat. It's just a picture out there, and it's really, really easy to do API testing. It's not that complicated. But just again, a quick show of hands. How many of you have testing in your web services layer or the API layer? Wow, this is amazing. I actually worked in a lot of teams which did not have that. So somehow the testing was limited to the unit testing or the UI testing. That middle layer was missing in quite a few teams that I worked on. And this is this is my favorite testing layer in the whole pyramid. It's really, really great because it's really stable. One of the biggest thing with API is when you're doing APIs testing, and I'm talking about the Java REST API stuff, whenever a change is coming into API, your signature of that API is changing, you always know that the change is coming because there is always going to be a paper trail. There's going to be a change in the requirement documentation. There's going to be a Jira ticket available for you which talks about that change. So that's a pretty big thing for API because on the UI side, you rarely sometimes get that notification that the UI is going to change. It can happen that a developer decides that, oh, I don't like the name of this button, or I want to change the attribute of a button. And then that impacts a lot of UI tests. With API, there is very less chance of that happening because API as such is developed by one team, consumed by not just one, but multiple others. So that change is like has far-reaching effects. So it's always going to come with you in a much more sort of like a structured manner. You will actually see a lot of documentation, a lot of heads up that your API is changing, make sure your tests are going to break, or make sure that you are ready to handle that change. There's that heads up that we get with API changes. And that's why they are much more stable. Second thing is faster feedback. So with API test, it's really much faster. It's not as fast as UI. It's immediate with a unit test, sorry. But it's much faster than the UI test. I wanted to actually see how fast is that difference. So luckily, I had one application that I was working on where you just had to log in, and on the first page itself, there was an API call being made behind the scenes. So I wrote one small UI test, a small UI test, where actually I logged in, I went to that first page, I validated some data on it. I wrote one small API test also for the same, where I directly made the call to the API, passing it the particular parameters it required, and then verified the response. So my UI test took me around 4 minutes to run. It was pretty simple, but still it took 4 minutes to run, while my API test, 30 seconds. So that's a drastic difference you see right there, 30 seconds and 4 minutes. You are saving so much time, and you are actually getting to test the core functionality, the core business logic of that API. So that's a pretty big advantage with API testing. Faster feedback, and directly you are going to the root of it, the functionality of your application. Lastly, these are again very easy to maintain. So as I said, the changes that come in, you are always getting a heads up of the changes, so you don't get blindsided by anything. And I have rarely seen that I have to go and fix something in the API unless that API endpoint has changed. I rarely have to go back and fix something. On the UI side, yes, multiple times. It can be page load, it can be change in the name of attribute, it can be some n number of reasons that can happen where I have to go and fix my test. But with API, there is a less chance of doing that. Lastly, APIs are developed by one team and sometimes consumed by the same, but sometimes by different teams in your application. Sometimes, in my case, it is actually being used by another company out there. So these are actually really good integration points. You are actually doing integration testing when you're testing your APIs because they are literally like the bridge between two applications, two modules. So you can really sort of put a lot of effort and put a lot of, you gain a lot of confidence if you're testing these APIs, basically. So these are the reasons why I think API are the best, and we should be really spending a lot of time on automating them and testing this particular layer. And this actually gives you the best bang for buck. So if you have to convince your decision makers, your management, or anyone, APIs are the best way to go because of all these things we have listed out here. And you save a lot of time because they don't run as slow as UI test. So you're saving on time, resources, maintenance resources, and so on. So you can actually convert this into sort of a monetary matrix and show it to your managers if you want to. So till now, I have been talking about API testing. But the biggest thing is this layer also takes care of web services, your WSDLs, your SOAP web services. So recently, I had this chance of actually practicing what I preach. My team had unit test and UI test, but missing the intermediate layer testing. And we were using Vistas because it was a pretty older application. We were using SOAP and so on. And at the time, I didn't have enough knowledge about web services. I had worked with Rest Assured and everything, but not the actual WSDLs and so on. So I took on that challenge and started off very small. I started off using SOAP UI, which is a tool. We have actually the sponsor out here upstairs. So I started using SOAP UI. I created a regression suite, a test suite for my WSDL, and I added assertions to it. I added some input and assertions. Simple assertions like schema compliance or just making sure I get a 400 or 200 response back, just the basic stuff. So I had my test suite ready for me. It was running perfectly fine on my local system. But just running it locally does not make it automated. You need to get it to run in your pipeline to make sure that you are really automating that particular process. So all I did was using a tool called Maven and some plugins in it, I was able to run that whole test suite on my Jenkins pipeline. Once I had that, that became my proof of concept. I had a report which was generated to me. It was a pretty basic report, not a fancy one, but it at least went through all the endpoints that I had assertions for, gave me all the errors, and so on. So I had all of this thing just by using a small, this was my basic POC to demo to my team, that we can do web service testing. It is not that complicated, and we can spend time on this because it's much, much easier to work on this rather than spending our time focusing only on the UI side. So that was my POC, and these were the few things I took into consideration: leverage SOAP UI, assertions, and run it in the pipeline. 3 basic steps that I did to get my POC out there. Once I have always seen this, if you actually do a small demo showing that something is possible, you are highly likely to get that buy-in from your team, from your managers, and everyone. So all it needs, if you put it in theory, it may not always work, but just having that small proof of concept, it will actually get you more buy-in from everyone. A few things to keep in mind with web services testing is there are a few things we just need to make sure that they are working as expected. One of them is, does your API work? It's a simple, like, does it work, meaning, do I get a response back? Do I get the status code? That's all you need to make sure for. Second thing is, does it work as expected? So you're actually here parsing the response that you're getting from your API or web service. Here you might require a little bit more technical skills. You will have to parse XML or JSON, but a lot of tools are available out there for us to help us with that if needed. All you're doing there is parsing the response, looking for some specific keywords or data, and that's it. Lastly, what happens for negative testing? If you're giving it invalid parameters, if your server is down, are you getting a response back, or are you getting any particular codes back? That's all you need to test for. So even with web services, if we keep it simple, you will really get a lot of advantage out of it and very less maintenance. So with this, we come back to our favorite layer, the UI testing layer. I spent some time telling you that UI automation comes with its own baggage, but it actually also has a lot of advantages that it brings with it. And one of the main things is end-to-end workflows. That's what you're looking for when you have a web application, that you have to be able to go from point A all the way to point B successfully in your application before you release it to the end users. So that's the main thing that you need to keep in mind with doing UI testing. It's very easy to go overboard and write all types of tests, check every single thing through the UI. But if you keep your UI testing limited to the end-to-end test scenarios, that would help us in the long run, reducing our maintenance workload. So this is the biggest part, how to figure out what's the critical functionality in your application. And that, I think, is the biggest task that you have with UI. Finding out what is the happy path that you need to test. Once you figure that out, writing the test, implementing it is, I think, it's pretty simple. So let's take this example. For an online course, we are trying to do is, as an online student, I want to enroll in a course, take a quiz, and make sure I'm able to submit it successfully. This is very important for online learning system. So these are the steps that you need to take. Create a user, enroll, perform the actions, and then verify submission successful. So to do this, it's very easy and I have seen this happen in a lot of places that, oh, I'm doing all these things, why not I start my test like this? I create a user, I try to create a course with invalid parameters. I fail. Then again, I create a course with good parameters. I pass. And then I start off with the rest of the process. So this is just sort of like an example, but the main point I'm trying to make here is it's very easy to get distracted when you're doing your workflows. If you try to test too many things and try to put too many things into your workflow, you will again end up with the problem that when you are troubleshooting it, debugging it, you will spend a lot more time than it's needed. So try to keep your test to the minimal. Focus on what exactly you're trying to do in your workflow. And for that, this is a test automation pattern that has been documented. There is a link to it at the end of my presentation to the website. But what this pattern tells us is like, focus on what exactly are you trying to do here. Even when you're looking for a good candidate from manual to automation, what are you trying to do there? Are you just converting the whole manual test to automation, or are you trying to figure out what is the purpose of this test? And then just focusing on implementing that particular functionality. So one clear purpose pattern is a pretty important thing that I have always used when I'm trying to write a test, which has a lot of complex workflows. I literally sit down and say, what am I trying to do here? And then move on with that. Another thing to keep in mind with UI testing is I always try to want to make my test more robust. And to do that, I leverage non-UI components. So non-UI components, I mean, are like database, APIs. Leverage those to do your data setup and tear down. Once you have that, it's really easy to then just focus on the navigation and the validations that you want to do. If you try to do the setup, tear down using the UI, you will again be spending a lot of time, and again there's a chance that it might fail at some point, stopping the whole test. So last thing, trust your lower level test. Now I'm assuming that by this time you already have your API test, your unit test in place. So if you are already testing your API, is there a need to also test the same thing from the UI? No. You can actually bypass it. So that's what I mean when I say trust your lower level test. If you have some testing in one layer, try not to duplicate the exact same thing in the UI layer, because already UI is expensive, as we all know. So there's one example I wanted to show about the best way of doing scenarios. The one scenario on the left-hand side is talking all about multiple ways you can do. You're trying to test all the entity creation in that side. While the scenario on this side is separating it out. My scenario is pretty compact. I actually have something called as background, which is like a setup annotation or a setup method that you might call. In that setup method, I'm calling and creating all my entities that I need for my testing. And in my scenario, I'm just focused on my critical workflow. Quick thing about the background, you can actually leverage APIs, as I mentioned, non-UI components. I'm creating a user, I'm making an API call here to do that. You could replace this with a database insert query. So you can do a lot of things as part of this setup and tear down. And that is where we sort of save time. And any time saved in UI is always great. It's literally time is money, as they say. So moving on to one thing, sometimes with end-to-end test cases, you always get a pushback that for our application, just testing the end-to-end workflows is not enough. We want you to test more. This enhancement has more UI elements in it. So we want you to do more of UI testing. In that case, I write something I call as my UI unit test. These are much more granular than the workflows. And they are, again, focus on one clear thing. I ask myself, what am I doing to test this particular feature? And that's the only thing I test. One example is if you log in as user 1, a table should appear on the page. While you log in as user 2, the table should not appear on the page. This type of test cases, I call it as my unit test, because all I'm doing is logging in as a user, going to that page, verifying the elements, and that's it. So these are my unit tests, UI unit test, as I call them. And lastly, I also leverage my UI test for accessibility testing. Coming from a government background, I actually have need to have Section 508 compliance. And that's what I do, sort of multi-purpose my UI test to also do accessibility testing, because either ways I'm going on the page, I'm going to interact with the elements, so why not do accessibility testing also at the same time? So these are the few things that we want to do as part of UI testing. Last but not the least, the cloud at the top that you see, it's actually talks about manual testing, but it's also something can be used for exploratory testing. And I think that's a very important term that's gaining a lot of traction in our testing community. The difference between manual and exploratory is that manual has more regimented test cases. You have your use case, you have your spreadsheet which tells you these are the things that you need to do, and these are the things that you should expect out of the step that you have taken. Exploratory testing, on the other hand, is more, as the word suggests, you're exploring the application. And the way I have done exploratory testing with my teams is we used to gather our whole team into a room for a duration of just 1 hour and make sure we just grabbed popcorn, chips, something to just, it was more an informal affair. And we just looked at our enhancement that we are planning on rolling out. Just sort of test that enhancement. We had our BAs in there, business analysts, we had product owners, we had architects, whoever was involved in that enhancement, we pulled all those people in, and we did something, as you all might know, bug bash. It was a type of exploratory testing for us. Some of us were new, so we were just exploring the application. Some of us were experts with that particular feature, and we were testing it. But it was a joint effort, and the biggest advantage of that was we got information, we got clarification from the actual people who are talking with the end users. We got feedback from people who are new to the application telling us, oh, I'm not sure what that button is supposed to do. It's not self-explanatory, or the UI is not friendly. So we got UX feedback from that experience. We made more sort of like we built up rapport with our team, which normally we don't get time if you're just working in your cube and doing your own stuff. Even with the planning and all, it's more formal. This was more informal, and it built those bridges that we really could use later on. So this is a very important thing, and I would suggest we at least, you try it out in your teams if you haven't done so. It may not be possible for all the enhancement or every release that goes out, but especially for a release which is more UI-centric, this is a really good way to go, rather than sitting and writing automation tests all the time. Another thing is something called as hackathon. I sort of put it here, though does it actually fall under exploratory testing? Hackathon, just to give a quick background, it was done in one of my teams where our teams were diverse. We were not just like geographically diverse. We were on the East Coast, West Coast, Europe, and other offshore countries. So it was very difficult to get our product to roll out on time. We were facing delays with coordination, communication, and so on. So our management decided to bring all of us together in one location for a duration of 5 days. And those 5 days we literally spent coding, hacking, and literally getting everything that we could get, at least get our questions answered. It may not have, we didn't end up with a complete solution, but we at least got those main things or the kinks in our workflow ironed out during those 5 days. Again, in that, we built a lot of personal relationships with the rest of the teams, rest of the members in other teams, who then we could reach out to if needed. Because just talking on the email or Skype, it's not enough. Sometimes that you need that face-to-face interaction to say, oh, I know this guy. I can just reach out to him and get the information I needed. So that actually was a very good experience. And I would really suggest if you can do that. There's actually one hackathon just after this session. So just give it a try if you haven't done so before. It's a really great learning exercise and a great tool for testing. With this, I would like to conclude my presentation with this last slide. These are the pointers I would really wish you guys take back from my talk. One of the things is diversify your testing. Don't just depend on UI to promote your builds, as you have seen. Use the pyramid as your guiding map. You can tweak it, customize it as the way you want, but use it at least as your guiding map. Give web service layer a priority. It's really, really a good way of testing, and I think a lot of people here I saw actually are leveraging it, so that's really great to see that. With UI, try to use your unit testing. If your push comes to shove, you have to write your unit test, but otherwise stick to the workflows and use APIs and web services for your data setup and cleanup. And for exploratory, just give it a try. It's really fun. It's a really good exercise to try out. With that, I would like to end my presentation. I would like to thank Selenium Conference organizers for giving me this opportunity, especially Ashley. And I would also like to thank all of you who are listening to me for the past 40 minutes. So thank you.